Hello, good morning, students. I hope everyone is fine. So, I welcome you again in my physics class. So, as you see here on your screen, we are doing ICSE physics for class 10, and now we have already started the Unit B of the ICSE syllabus, and the Unit B consists of the topic called light, or we can call it as optics. Here, the unit has been divided into three chapters. One is refraction through plane surface, the other one is refraction through curved surface, that is through lens, and the third one is spectrum. So we are supposed to learn three chapters, and we have already begun with the first unit of the first chapter, that is refraction through plane surfaces. So I have already discussed you about refraction, about the cause of refraction, the factors on which refraction depends, and also the laws of refraction on which our refraction depends. We also learned about refractive index in the last videos, okay, and we've learned three relations to calculate the refractive index. One is with the ratio of sine of I to the sine of R, that is angle of the sine of angle of incidence in the medium 1 to the sine of angle of refraction in the medium 2. Then we also learn about the refractive index with respect to the speed of light in air or in vacuum to the speed of light in the medium that you are talking about. And the third one was refractive index, or you can say the calculation or finding out the refractive index of a medium, second medium, with respect to the first medium. So today we'll be trying to wrap up the first unit of the chapter. So now today we are going to the discuss about two main topics, that is lateral displacement and the reflection or the multiple images formed when a ray of light is incident on a thick glass plate or a thick mirror. All right, so let's begin. So today's discussion will be on our lateral displacement. The first discussion that we are going to begin is lateral displacement. Now displacement, now you know what do you mean by displacement. You know the terminology of this word displacement. Displacement means to move or to change the position, isn't it, from one place to another. But here one more word is attached to it, that is lateral. Okay, lateral displacement. So here the terminology of lateral means to move. Okay, the exact meaning would be to move aside. Okay, move aside, or you can write towards, okay, or to the sides. That would be the meaning. So here we are dealing with a chapter called light. So here the ray of light gets displaced. How? Laterally, when it is allowed to pass through a thick glass slab or a glass block, and the block should be rectangular glass block. So we will try to understand the concept behind this lateral displacement, that is the displacement of ray of light when it passes from air to the glass and then again from glass to the air. Are you getting my point? So for this, let me take a rectangular glass slab. So I have a rectangular glass slab. Let me name this as PQRS, or you can name as per your wish. Okay, suppose I have a point O here, and this is the point at which my incident ray AO. So here my AO is incident ray. Okay, so it's striking here on the surface PQ. So this is my rectangular glass block. So here I have my air, this is my glass, and here again I have my air. So you know it is striking on the surface PQ. This is my surface PQ at point O. So at point O, I will be drawing the normal and I will name that normal as NM. So let my normal, the first normal for the surface PQ be NM. Now you know that the ray of light AO is now, okay, passing from A to air towards glass, that is changing the medium. Air is rarer as compared to glass, so it is clear now the ray of light is moving towards the denser medium from rarer medium. So if I draw the direction of the incident ray, this is the direction of the incident ray, isn't it? Yes, but now since the ray AO is traveling from air to the glass, that is rarer to denser, it will bend towards the normal. Are you getting my point? So this will be my refracted ray. Okay, so let me name it. Okay, so this ray is my what ray? Refractive, okay, ray. See, first one, this one is my incident ray. You must know, you must be able to recognize all the rays. Okay, so incident ray AO. All right, now the refracted ray is now striking here on the surface SR. All right, and let that be point B. So here is my point B. All right, so at point B, the ray of light, okay, after refraction is striking on the surface SR. Now at B, I will draw the normal. All right, this is my normal. Let that normal be N dash and M dash. Are you getting my point? Now if you see that OB is the ray which is now inside the glass. So it is now traveling from glass towards the air, because now the ray will come out of the glass slab. So glass slab बाट बाहिर निस्किँदाखेरि चाहिँ के हुन्छ? It will be traveling from glass towards the air, that is from denser to rarer. So it will bend away from the normal. So this would be my emergent ray. So यो चाहिँ के भयो? बाहिर निस्क्यो नि त. So let me name it as C. So now my BC, okay, so my BC, okay, let me draw with another color here. So here this ray is my now, okay, I need that space. So let me name here, this is my which ray? Emergent ray, niskeko ray, emerge bhako ray. So emergent ray. So here we saw three rays. One is the first one, AO is my incident ray, OB is my refracted ray, refractive ray or refracted ray, okay, and BC is my emergent ray. So now if you see the result or the outcome here is that the ray, if there was no glass slab, if this glass slab or the rectangular glass block was not there, the ray of light would have traveled in this way, isn't it? That would be the path. But since now the ray of light has to pass through the glass slab, now the ray is coming out of the glass slab and it is following this path, isn't it? So now it has been shifted here, see, from this point to this. So it is now laterally displaced. So this phenomenon is called lateral displacement. Are you getting my point? Did you understand here? So lateral displacement means the shifting of ray of light, okay, when a ray of light is allowed to pass through a rectangular glass slab. रेक्टेंगुलर ग्लास स्ल्याबबाट रे अफ लाइटलाई चाहिँ छिरायो भने चाहिँ त्यसले आफ्नो पाथ चाहिँ के गर्छ? ल्याटरली डिस्प्लेस गर्छ. दिस फेनोमेनन इज कॉल्ड lateral displacement. Are you getting my point? Now your assignment would be to write what, number one, what do you mean by lateral displacement? Are you getting my point? So see, whatever the assignment I'm giving today, these are the questions that has come in the ICSE. Okay, now the other one is to draw this figure and locate the lateral displacement. So how are you going to locate the lateral displacement? You will draw this diagram. Okay, you will draw this diagram, and after drawing this diagram you will mark a perpendicular. We'll draw a perpendicular to connect these two parallel lines. This would be your, okay, lateral displacement. Understand? This is how you will write. So this is your second assignment for today. Okay, you can copy the figure from your book. It's there in the book. All right, so this is your first topic for today. So I hope you have understood. See, if you have any confusion, I'm always there. Okay, you just ask me in the class group or you can text me personally. All right, so now let's go to the next topic that we are supposed to discuss today, and that is our this one, multiple image in a thick plain glass plate or a thick mirror. Okay, so we are taking a thick mirror. So if I take a thick mirror, what will happen to the ray of light which is incident on it? That is what we are going to learn here. So I have a thick glass, okay, and this small dotted lines, okay, indicates, what does it indicate? It indicates that this one is polished surface or the colored surface. All right, clear? So this is my thick glass plate. Is that okay? Yes. Okay, now let me take one point object. This is my point object A. From the point object A, two rays are incident on this thick glass plate. Okay, one is this one which is striking on this surface here. Are you getting my point? After this, what will happen? It will reflect back in the same path. Are you getting my point? So I will draw the dotted lines here. Is that understood? Okay. Now let me draw another ray of light coming from the same point object A, which is incident here at point B. Now when it is incident at point B, two things happens. You all know that, isn't it? One is reflection. Reflection will take place, isn't it? Yes. And when the ray of light is striking on this glass, the other phenomenon that will occur is some ray of light will, what happen? It will pass through the or into the glass. That is, refraction will occur. Now since it is traveling from air to glass, so it will bend towards the normal. So it will be striking here. Now at this point, what is happening? At the point, if I have to name it, let me name this as B dash. At point B dash, what happens? Reflection occurs because this one is the polished surface. So reflection occurs here. Are you getting my point? Yes, this is my reflected ray. Okay, at the point C. So B dash C is my reflected ray. Now again at this surface, two phenomena will occur. One is reflection, the other one is refraction. Now since the ray of light is traveling from glass towards the air, that is from denser to rarer, so it will bend away from the normal. So this will be my emergent ray, isn't it? But some part of it will get reflected back in the same medium. So this is my reflected ray, which is now going to C, towards the C, points C dash, isn't it? So here what I'm trying to teach you is that at each and every surface, okay, what is happening? Reflection and refraction is taking place. Okay, on the surface M, suppose if I name this as M dash, M dash ma चाहिँ के हुँदैछ? Reflection, refraction दुईटै हुँदैछ. But if I name this as N dash मा चाहिँ reflection मात्रै हुँदैछ. Why? Because this one is polished surface. यहाँबाट चाहिँ light छिर्न सक्दैन नि त. This polish makes it opaque. त्यहाँ light छिर्न सक्दैन, so only reflection takes place. But the surface, okay, but this surface MN, यो चाहिँ के छ? This is the point through which light can enter as well as reflect. So your point मा चाहिँ you can see that reflection, refraction, दुईटा take place गर्दैछ. Alright, so now it has come to point C dash. C dash बाट पनि यहाँ के हुन्छ? Reflect हुन्छ, right? So reflection will take place and now it will strike on the surface MN, M dash at D. Now here it is traveling from glass towards the air, so refraction will occur, isn't it? And some part will get reflected back. So this phenomenon will take place. It will continue till the intensity of light has becomes minimum. Okay, so now when I produce these rays backward, okay, it is going to meet here. So here, this is the point where my image of this A will be formed. So here it will be A1. Similarly, when I produce this backward here, it will be A2. When I produce this backward somewhere here, I'll get A3. So I will be getting multiple images. So now what I'm trying to tell you here is that due to this multiple reflection and refraction taking place on the surface, okay, of this thick glass plate or thick mirror, के हुँदैछ, मल्टिपल इमेजेस आर फर्म. सो एउटा नक्सा, एउटा पोइन्ट थियो नि त यहाँ ए, यो पोइन्टको चाहिँ यु आर गेटिङ मल्टिपल इमेज हियर. A1 is the first image, A2 is the second image, and A3 is the third image. So here I have drawn three images, isn't it? So here you see that multiple images are formed. Okay, are you getting my point? So did you understand here? So now one very important question is asked in this question, in this thing. What do we say? Topic is which image will be brightest. The question is which image is going to be brightest. So the image that is going to be brightest will be A2. Now why A2? See, let us again follow back. Okay, let me change the color of my pen. Now see, now you know that the incident ray which is striking at point B, some part is getting reflected, some part is getting refracted. So here if you see, what will be the intensity or which refracted ray को कि reflected ray को intensity बेसी हुन्छ भन्दाखेरि चाहिँ refracted ray. Reflection चाहिँ एकदमै कम्ती मात्रामा हुन्छ यहाँ point B मा, but refraction will be more. So this ray will be more intense. So that will get reflected from B dash and strike here. So यहाँबाट अझै के हुन्छ, refraction will be more as compared to reflection. So when you produce this backward, your image A2 will be the brightest. Are you getting my point? A2 will be the brightest. So what will be the reason? Reason is that the light suffering here is due to the strong first reflection. Your first reflection हुँदैछ नि त यो point B dash मा हैन, यो reflection त के छ, strongest छ अरु reflection हेरी. Are you getting my point? So today's third question for your assignment is, okay, like you can write this as a question. During the multiple image formed by a thick glass plate or a thick mirror, which image is the brightest? So your answer will be image A2, or you can write the second image will be the brightest image. Okay, why? We'll write the reason as due to the light suffering a strong first reflection at the silvered or the polished surface of this mirror. Are you getting my point? So as you see the other images A3, A4, A5, A6, it continues, they will gradually be decreasing in brightness. So first image पनि bright हुँदैन, second image will be the brightest, and then the third, fourth, fifth images त के हुन्छ, तिनीहरुको brightness त के हुँदै जान्छ, घट्दै जान्छ, because the intensity of light will also decrease. Why? Because it is suffering multiple reflection and refraction. All right, so here we understood that the reflection and refraction is actually causing the formation of multiple image, okay, of a single object which is kept in front of this thick glass plate or thick mirror. All right, so I hope you all understood this. Again, I'm telling you, if you have any queries, I'm always there. You just ask me. Okay, clear? So that's all for today. Thank you.